If you're manually invalidating your entire CDN cache every time you deploy, you're probably paying more than you should and your users are experiencing unnecessary latency spikes. I'm going to show you the 3 cache invalidation strategies that cut our clients' invalidation costs by 85% and improve their cache hit ratio from 60% to 94%.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm excited about this one because I've definitely been guilty of just hitting that invalidate all button.
And you're not alone. Today we're diving deep into GCP Cloud CDN cache invalidation, and I promise you'll never look at that invalidate button the same way again.
So let me set the stage here. We deploy our application, some images or API responses are stale, and my instinct is to just purge everything. What's actually wrong with that approach?
3 things. First, cost. GCP does charge for cache invalidations, and while there is a free tier, you'll want to check the current pricing at cloud.google.com/cdn/pricing since the specifics can change. But trust me, aggressive invalidation adds up. Second problem, you're hammering your origin server. When all those globally distributed edge locations simultaneously request fresh content, your backend gets crushed. Third, your cache hit ratio tanks, meaning users experience slower load times until the cache warms back up.
Okay, that makes sense. So what's the smarter approach?
Think of cache invalidation like recalling products from store shelves. You wouldn't recall every product in every store because one batch of cookies was bad. You'd recall only the affected SKUs from the affected regions. Same principle applies here. GCP Cloud CDN gives you several invalidation approaches, and choosing the right one is crucial.
Walk me through them.
Strategy 1 is path-based invalidation. You specify exact URLs like /images/logo.png or use wildcards like /API/v2/star. In the GCP console, you navigate to network services, then load balancing, select your load balancer, then your backend service, and find the cache invalidation option there. The console UI does change periodically, so poke around if the exact location shifts. For the command line, you use GCU Cloud Compute URL Maps invalidate CDN cache followed by your URL map name, then the path flag with your specific path. So something like G Cloud Compute URL Maps invalidate CDN cache my URL map path equals /API/pricing/star. The key is being surgical. If you updated your pricing API, invalidate that specific path, not your entire cache.
That makes sense for planned updates. But what about when content changes dynamically, like user-generated content?
That's where strategy 2 comes in. Cache key configuration with query parameters or request variations. Instead of invalidating after the fact, you design your cache to automatically serve fresh content based on different cache keys. The most straightforward approach is using version query parameters in your URLs. When you update content, your application generates URLs with a new version parameter, like $v=2 instead of v=1. The CDN treats these as completely different cache entries because the URL changed.
What about using custom headers for cache keys? I've heard that's possible.
It is, but it's important to understand how it actually works. You can configure your backend service's cache key policy to include specific HTTP headers using the include HTTP headers setting. But here's the key point. Those headers need to be present in the incoming requests from clients, not just set on your server. So you'd either need your clients to send a version header, or you'd use request header transformations to add them. For most use cases, the query parameter approach is simpler and more reliable.
Got it. So what's the third strategy?
Strategy 3 is proper TTL management with cache control headers. For time-sensitive content, you set appropriate max age values in your cache control headers. Content automatically becomes stale when the TTL expires. No manual intervention needed. You might also use signed URLs for access control, but I want to be clear about something. Signed URL expiration and cache expiration are two completely separate things. A signed URL's expiration controls whether someone is authorized to access the content. Cache control headers control how long content stays cached. You need to configure both appropriately, but they work independently.
Oh, that's an important distinction. So a signed URL could expire while the content is still cached?
Exactly. Or the cached content could expire while the signed URL is still valid. They're orthogonal features solving different problems. Signed URLs handle authorization, cache control handles caching behavior.
Let me make sure I understand the 3 strategies then. Path-based is for surgical strikes after deployment, cache key versioning through query parameters handles dynamic content, and proper TTL configuration with cache control headers manages time-sensitive content automatically.
Perfect summary. Now here's where people mess up. Mistake 1 is using wildcard invalidations in C/CD pipelines. I've seen teams trigger/star invalidations on every single deployment. They had 50 deployments per day and wondered why their origin servers kept crashing. The fix was implementing cache key versioning and only invalidating specific changed assets.
What's the second common mistake?
Misunderstanding how Cloud CDN's TTL settings interact with origin headers. Cloud CDN has several TTL settings in the CDN policy configuration. There's default TTL, which applies when your origin doesn't send caching headers. There's max TTL, which caps the TTL regardless of what your origin specifies. And there's client TTL, which affects what gets sent to end users. When your origin sends a cache control max age header, Cloud CDN uses the minimum of that value and your max TTL setting. The default TTL only kicks in when the origin doesn't specify caching behavior. So if your origin says max age equals 86,400 for 24 hours, but your max TTL is set to 3,600, your content expires in 1 hour. Check your CDN policy configuration in the console under your backend service settings.
So to recap, first, be surgical with invalidations using specific paths instead of wildcards. Second, use cache key versioning through query parameters for dynamic content to avoid invalidations entirely. And third, understand how your cache control headers interact with Cloud CDN's TTL settings, specifically max TTL, default TTL, and client TTL.
Nailed it. And here's my pro tip. Enable Cloud CDN logging and export to BigQuery. Run a query to find your cache hit ratio by path. Anything below 80% is a red flag that your invalidation strategy or TTL configuration needs work.
That's actionable. I'm definitely checking our cache hit ratios today.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone who's struggling with CDN performance or unexpected cloud bills.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.